Okay, for this video, we will talk about chapter 8.1, and it's about conditional probability. For conditional probability, you've learned it in the compulsory part, but here for module 1, we will talk about it more deeply. To start with, we should talk about the Venn diagram. We have two events A and B, and we can say that A and B can happen together or not A or not B. That means none of them happened. Let's sheet these regions. And what can we say about the probability of A happened? Probability of A is the yellow part and the green part. We say that the circle for that is for A. Then how about probability of B? The probability of B to happen is the green part and the blue part. That means the circle for that. Then of course we can talk about the probability of A union B and probability of A intersection B. For union, probability of A union B is like probability A or B. So that's why the region will be the yellow one, the green one, and the blue one. For the probability of A intersection B is similar to, actually it means the probability of A and B. So that's why it's only the green part. So in this case, we know that for probability of A union B, you know it is equals to probability of A plus probability of B, and then minus the probability of A intersection B. So this is the very basic concept for probability. And we talk about that conditional probability, which means we will have another symbol, it's something like this, or something like this. So this is the probability of A, the first one is probability of A given that B, and the second one is probability of B given that A. What does it mean? It means that for this case, given that B happened, then the sample size is the probability of B. And then that A happens is only this green part. For the other one, that means the right hand side, you can see that is the same meaning. Is that the probability of B happened when A is already given. So the sample size is A, and then B happened is also this green part. So that's why we have this. So this is about the conditional probability. So probability of A given that B is equals to that the denominator will be probability of B, and the numerator will be probability of A and B, that means A intersection B. So similar to that for the right hand side. Then the question is, what if we have something like this? The conditional probability, let's say is the probability of not A given that it is not B. What would it be? So you think about that it would be the probability of this one equals to the probability of, we know the sample size will be the probability of not B, and then we have to know that both of not A and not B happened here. So for the color, okay, you can find it out would be something like this. The probability of not B, that means this one yellow part and the red part from the Venn diagram. Okay, this is the probability of not B. And then for probability of not A intersection of not B, that means they have to both not A and not B. So it is the red part only. So the numerator will be the red part. So you can calculate it once you know the values. So you can look at page 10 of the textbook. You can find out these properties. And we can say that for the last part here, if we want to say these two adding up equals to 1, you know it means, from the Venn diagram, you know it means something like this. The green part and the blue part is the probability of B. So given that this happened, not A or and also A, adding them up, the probability equals to 1 here. Okay, so let's look at an example here. So in this case, there are 40 students, and some of them have done the revision and some of them haven't. And we found that the who have passed it, so some of them has done revision and some of them does not. So we can find out it by using a table. So we've drawn a table to show that pass or not pass, and has done the revision and hasn't done the revision. So we know that who has passed the test, 27 of them has done the revision. So this one is 27, and 3 of them have not done revision. This is 3. And altogether 28 of them has done revision, so that 1 of them does not pass, and the remaining number will be 9 because total number of students will be 40. So by using this table, you can know about each numbers. Okay, so for part A, given that the status student has done revision, find the probability that he passed the test. So for part A, what we are going to do is, given that this is a revision and then pass the test, so this is something like this. So by using the definition, you know that we have to find the probability of this one, revision, and then probability of pass and also has done the revision. So in general, if you use the probability, which means the altogether the possible outcome was 40, and then do the revision is 28 over 40, and pass and revision is 27 over 40 as well. So that's, in this case, is actually, you know, it's 27 over 28. Then look at the part B. So given that it has not done revision, so find the probability she passed the test. So that means, given that this has not done the revision and passed the test, so it's something like this. So find this probability, it means we have to find the probability of not R first, and then both pass and then not haven't done the revision. So of course, if you find the total number of students, you can also use that number. So which means that is 3 plus 9 altogether, and the probability of both have passed and then not done the revision is 3. So this is also 3 over 12, so it's 1 over 4 in this case. Then for part C, given that has not done the revision and then does not pass the test. So in this case, it's something like this. You can use 1 minus this probability, okay? And that's why it is 1 minus 1 over 4, then you can get it's 3 over 4. But of course, you can find it out is 9 over 3 plus 9. So of course, the answer is also 3 over 4. Let's look at another classwork 8.2 on page 12. You can see there are some given probability, the values. So we can also use the Venn diagram to help you. So which means if I wrote the probability of A is equals to, you know that is the yellow part and then plus the green part. And this part equals to 0.3. And probability of B, you know this is the green part and then plus the blue part, and it equals to, that is 0.25. And the probability of A union B, it means we have to count all of them, that means A or B. So we have the yellow part and then plus the green part and then plus the blue part. It is equals to, that value is a 0.45. So this is the given information. By using this given information, you can find all the value for part A to D. So first of all, for part A is probability of 8 and B, that means intersection of B. It means that the green part, so this is adding the probability of A and then plus the probability of B minus the probability of A union B, that means probability of A or B. So that's why it's 0.3 plus 0.25 and then minus 0.45. So it is equals to 0.1. So you know the green part here is actually equals to 0.1 in this case. Okay, and then let's do part B, C, and D. So for part B here, so it's a probability of given that is B and then it is not A. So which means I have the probability of B first and then probability of not 8 and then B. Okay, so this is meaning that it is the union, the intersection of this one. Okay, then next, probability of B, we know that is the green and then the blue one. And then if by using color, so you can use it as the green part plus the blue part, and then not A and also B. So this means you have to find is the blue part. Okay, it's something like this. But how to find it? Actually, you can see it as 1 minus. That is something like this. Of course, you can also see it in this way, which means you can see it's 1 minus the probability of this one over this one. So that's why you can say it's 1 minus, and then this probability already found is 0.1, and this is 0.25. So altogether is 0.15 over 0.25, so this is 0.6. Okay, so this is part B. And then part C. So probability of that B given that is not 8. How to find this one in this case? You know that it equals to the probability of not 8 at the denominator, and then for the numerator will be these two to happen together. So by using the color, you know that the probability of not 8 is the red part and then plus the blue part. And then for not A and B to happen, actually it means that the blue part here. So somehow you can find it in this way. Instead, it's like something like this. This is 1 minus. This is the probability of A. So you can find it is 1 minus 0.3. And then the numerator is the blue part. Blue part, you've already found it is 0.15. So in this case, you can see it's a 0.15 over 1 minus that is 0.7. So this is the probability. So in this case, maybe we use a fraction to write it. So it's like this, 14 and 3 over 14. And then for part D, so the probability of that means it is, so let's rewrite it here. So we can have this as the numerator, is that the denominator is given that the given condition. So this probability to happen. And then probability of A and then intersection of this A union B. A intersection A union B, that means A union B and A has to be happen together. So that means actually this is probability of A. So that means it's something like this, the yellow and the green part, and then this is the probability of A union B. And both of them, you know it, is 0.3 over 0.45. So that's why in this case it's 2 over 3. Okay, at the same time, we will see that conditional probability will be something like this. This is what you have learned in the compulsory part. So part A in this question, 1 boy and 2 girls in the team. So these 3 students has to randomly selected. So out of 8 boys and 4 girls. So you are using is also a conditional probability, but we will say it the required for bit, okay, the probability of 1 boy and 2 girls. So you can have something like this. First of all, 12 of them, we try to find 3 randomly, so 12C3. And then the combination will be 8 boys, we choose 1, and then we have to multiply it by 4 girls, we choose 2. So by using the calculator, the value here is 12 over 55. Okay, so part B, at least 1 boy and 1 girl in the team. So that means we have at least 1 boy and 1 girl, so we have the required probability, okay, required probability equals to that, not just the part A, the answer in part A is one of the possible outcome. The other one would be 2 boys and 1 girl. So we have the part A answer and also adding this. So the value will be 8 over 11. Okay, and then part C, exactly 2 girls in the team given that. So you have to look at the question very carefully. Given that at least 1 boy and 1 girl are selected, That means the given probability will be the answer of part B. And that exactly 2 girls in the team. So which means I need to use is the part A answer. That means 12 over 15, 5, and then over 8 over 11. So this is the case, then the answer will be 3 over 10. That's the answer for part C. Okay, so for the conditional probability, we can rewrite it by this method. So this is the probability of A, we multiply it by this given probability of A and then B. So that this is the probability of A and B, something like this. So this is called the multiplication law of probability. And why do we want to do this? Because sometimes we need to know whether the 2 events are independent events or not. For independent events, it means that given that B happen, the probability of A is actually equals to the probability of A. And also, so the probability of B is that the same as given A. So that means no matter A happened, B, the probability of B is the same. Or in this case, no matter whether B happened, the probability of A does not change. So in these cases, that means A and B are independent. So that's why we can say that if we want to check whether the probability of whether A and B are independent, then we can check this. So that means the probability of given that A, B here is the same of probability of B, or the other way around. Either of them is true, then this one is true, and A and B are independent. But of course, if one of the events is this one equals to 0, it's an impossible event, so we don't need to talk about whether they are independent. It is meaningless. But in the case A and B are independent, you need to note the other cases, A and not B, not A and B, not A and not B are also independent. Okay, so let's look at another example on page 15. It's about the conditional probability, which is we need to talk about the independent event. So what it means. So in this case, there are 2 baskets, A and B. For A, you can see that that the difference is that for A is without replacement, but for B is with replacement from basket B. So that means for A, we can say that without replacement. So the second one and the first one, they are dependent events. But for with replacement, that means for this basket B, because you will put back the apples or pears back to the basket. So that's why the first one and the second one, they are independent events. So we need to know about dependent events and independent events. So for part A, how to find that? So part 8, 2 different pieces of fruit from basket A. So in this case, you know you can use the combination because they are all together 10 fruits and then choose 2 of them. So you can find it in this way. Or you can say that the first one, if I've chosen the apple, and then the second one is dependent event, so that's why it is out of 9, we choose 7. And of course, you have to add the other possible outcome is that first one is the pear, and then the second one is the apple, but it's out of 9. So that means this is a dependent event, okay? And then the value is also, you can find it out, is 7 over 15. Okay, and then it's about the part B. Part B is exactly 2 apples from the basket. Of course, you can say that out of 3 apples, you choose 2, and then none of the pears has been chosen. And then you can use this combination to find it out. Or you can say 2 of them are apples, so this is 3 over 10. And then without replacement, so out of 9 of them, you only have 2 apples left. So the probability can be found out like this. So the answer is 1 over 15. And then part C, This is the basket B. Basket B is with replacement. So that's why if you say that the exactly 2 apples from basket B, so you can say that the first so choose it one by one, and then 10 out of 10 of them, you know that 2 of them are apple. So the first case is 2 over 10 to choose one apple, and then the second one to choose an apple is also 2 over 10, but one of them is not the apple because you have to snap 3 out of 3 pieces of fruit, so one of them is not apple, so 8 over 10. So it can be here, the last one is the pear and the first 2 are apples. So you know that the orders can be changed. That means by using the very basic concept, the first one is pear, and the second one apple, third one apple, and also the first one apple, second one pear, and the last one is apple. So it's actually multiplying by 3. And then what is the result here? So it is 12 over 125. And then part D. Sandy select 2 apples from at least one of the basket. Okay, so what it means. Okay, and then part D. Part D would be like exactly 2 apples from at least one of the baskets. So what it means. It means that if we don't have any basket have exactly 2 apples, and they use 1 minus that. So that's why it is 1 minus, the probability is 1 minus. This is the 1 minus 1 over 15. That means not exactly 2 apples, okay, from basket A, and at the same time not exactly 2 apples from B. So for this probability, that means not exactly 2 apples from either A or B. So and then 1 minus this one, then the result is this. 1 minus 1582 over 1875, and then the result would be 293 over 1875. And the next page, page 16, is classwork 8.5, a very typical question to ask you whether the 2 events are independent or not. So first of all, let's do part A. So part A is to find the probability of not 8 intersection B. So which means it's the probability of not 8, and then plus probability of B, and then minus the probability of not A union B. So you can find it in this way. It's 0.3 plus 0.15, and then minus 0.4. So this is 0.05 for part A. So to check whether for part B, A and B independent, we can check not A and B, whether they are independent. So we would like to multiply the probability of not 8 with probability of B. So this is 0.3 times 0.15. And what you get here is 0.045, which is not 0.05. That means it is not equals to the probability of the union of not A and B. So in this case, therefore, the A and B, not A and B are not independent. At the same time, so A and B are not independent as well. So you have to do this in this way. So on the same page, you can find this, the multiplication law can be extended, okay, to more than 2 events. So let's say there is an event A1 and then A2, A3, so on, and then to AN. We want to find that the intersection of all A1 to AN. We can say that it is a chain reaction, like the first one is probability of A1, and the probability A1 happened, and then the probability of A2, given that A1 happened. And then given that A1, A2 happened, and then A3, so on and so on. So this one multiplying together, you can get this the probability. Okay, so if they are all independent events, so the probability would be, we can just say that multiplying each of them together to get the intersection of A1 to AN, okay? And then, so what do we use it? When do we use it? Okay, so let's look at a problem here. So it is saying that some customers are housewives, and the housewife, some of them are VIPs, and then who are housewife and VIP, and 30% of them purchase more than twice in a week. So, and then it said that any customer who are not VIP members purchase twice or less in a week from Bakery X. So we solve for part A, B, and C respectively. So for part A first. So for part A, it means that it's a housewife and also a VIP member. So first of all of them 45% of housewife, and then out of them, so 80% is that are VIP. So you can multiply 0.45 to 0.8. So you get 0.36 would be that probability. And part B is that housewife and purchase more than twice in a week from Bakery X. Because it purchases more than twice in a week, it means that it's a VIP member. So this one is actually means VIP. Okay, VIP, and purchase more than twice. Okay, also purchase twice more. So it must be a VIP first. So this is for part B. The probability is first of all is a housewife, 0.45, and out of those housewife, 0.8 are VIP, and out of them is 30% to taste twice in a week. Okay, more. So you can find that the probability is something like this. So it is 0.108. And part C, the customer is a housewife and does not purchase more than twice in a week. So what would it be? So let's say I let purchase more than twice, okay, be this one, this the event, be the event of purchasing twice or more than twice, something like this. So in this case, let's say I let housewife be H, okay, let H be the let H be the event, okay, event of a housewife, something like this. So that means for part C, what you're doing is to find out that the probability, the required probability, is to find out that the probability of housewife, okay, minus probability of housewife and purchase twice in a week. So probability of housewife is 0.45, and the minus that is this one, also actually is a VIP. So this is the answer for part B. So that's why the answer is just this one. Let's look at page 17 for the stage assessment. For question number 1, so part A, you have to find the probability of A intersect B, so which is probability of A plus probability of B minus the probability of A union B. So which means the first one is 1 minus 0.4, and then plus 0.48, and then minus 0.9. So in this case, you know it is 0.18. In part B, probability of B given that A equals to probability of A first, and then for the numerator is A and B together. So it's 0.18 over 0.6. So that's why it is 0.3. And then part C, probability of A given that B is that the probability of B as the denominator, and then the numerator is A and B. So it is probability here is 0.18 over is 0.48. So that's why it is 3 over 8. So it is 0.375. And then for part D, so part D here, you have to find this probability. Given that B, not A, it means that 1 minus this one. So because given that B happened, A will happen or not happened. So this event, okay, so this is a 1 minus the answer for part C. So that's why the answer is 0.625. So this is question number 1. And then question number 2. So A and B are two events, and then probability of A is equals to K. So part A, you have to find the probability of A, okay, and B. So this is probability of A plus probability of B minus the union of probability A union B. So this is K and then plus 1 over 2 and then minus 11 over 18. So that's why in this case we can write it as K minus 1 over 9. So part B. So we've known that probability of this, given that A, the probability of B equals to 1/3, it means that probability of A is the denominator and then the numerator is A and B equals to 1 over 3. So this is K and then K minus 1 over 9 equals to 1 over 3. So 3K minus 1 over 3 equals to K. So eventually you can find out that K, so 2K equals to 1 over 3, so K is 1 over 6. Okay, and then part C. So probability of that, as I said, this case, so given that not A and then B, what would it be? It becomes the probability of not 8 and then probability of B and also not A. For the numerator, probability of B and also not A, you have to make sure that you understand it means something like this: probability of B minus probability of both B and A happen. Okay, in this case, you use this as the numerator, and the denominator, of course, you know that this is 1 minus K, so this is 1 minus K, 1 minus 1 over 6. So in this case, you can find out that this one is 1 over 2, and then minus that is K minus 1 over 6, 1 over 9. So this is 1 over 6 minus 1 over 9. Then you can find out the result, and then 5 over 6. So therefore, the result is 8 over 15. So this is the question number 2. Okay, and then question number 3. Question number 3, so what would it be? Okay, so you have to look at the question carefully. So some of them does not satisfied, and among them were satisfied. Okay, in this case, you need to highlight the information. Okay, who are satisfied, 10 of them does not receive. So find the probability of this event. Now maybe we use a table for that first, or we can use a tree diagram like this. So we can find out the probability in this case. Okay, satisfied 82%, not satisfied 80%, so on. You can write down all the probability for the tree diagram here. And then part A, so you are finding that the customer satisfied and has not received the product on time. Okay, so that means you have to find the probability of satisfied and not on time, so R prime. So this one is probability of S times probability of given that S happened, and R prime. So this case is 82%, okay, or 0.82 times the other one. This one is 0.1. So this is 0.082 for part A here. Okay, and then for part B is to find out that it's not satisfied and has not received, and has received. So probability of not satisfied and has received. So given that this is a probability of not satisfied times probability of given that not satisfied but receive. Okay, receive this the product on time. So that's why in this case is 0.18, and then times the receive is 0.45. Okay, so in this case the result is 0.081. Okay, so this is how you do for question number 3C. And then the last part is the homework. Just do the multiple fold the questions for that. Okay, for A1, that's the end for this part.